The drinking bird is a heat engine that works at room temperature with a low boiling point liquid. To begin the drinking bird's motion, you must first wet its head. When the water evaporates from the fuzz on the dippy bird's head, the head is cooled. The temperature decrease in the head condenses the liquid inside, decreasing the vapor pressure in the head relative to vapor pressure in the abdomen. The greater vapor pressure in the abdomen forces fluid up through the neck and into the head. As the fluid enters the head, it makes the dippy bird top-heavy. The bird tips, the liquid travels to the head, and the bottom is no longer submerged in liquid. Vapor bubbles travel through the tube and into the head. The liquid drains from the head, displaced by those bubbles, and fluid drains back into the abdomen, making the bird bottom-heavy. This re-wets the bird's head and tips the bird back up, restarting the cycle.
You may wonder, why do we need a glass of water for it to work? As explained earlier, the dippy bird is a heat engine that works due to the temperature differences of the two bulbs. The glass of water ensures that the felt covering of the bird's head remains wet, so that evaporation may continue to occur, which helps cool the head and condense the methylene chloride vapor present. A common question may be, does it work better with cold or hot water? When looking at how the dippy bird works, the answer would be it works better with cold water, as the process relies on the cooled head of the bird to condense the vapor. Using cold water enables the cooling process to occur at a much faster rate. If hot water were to be used, it would have the complete opposite effect, heating up the methylene chloride vapor instead. This causes the liquid to remain at the bottom of the bird, and thus the dippy bird just stands up straight. If a glass of cold water was placed under the bird's bottom and another for it to drink from, slight movement will take place due to condensation occurring at both ends. The bird will eventually tip and remain in said position unless heat is introduced.
Now that we know how the tippy bird works and what happens with a cold base and cold drink, what about other combinations? So what happens when the tippy bird's base is cold and the cup it's drinking from is filled with hot water? As heating the methylene chloride causes the bird to tip, cooling it was expected to keep it steady, which is exactly what happened. The methyl chloride vapor was not heated and therefore did not rise to the head, so the bird didn't get top heavy and didn't drink. But what if that was reversed? What if the bird's base was heated but the drink was cold? As explained previously, methyl chloride has such a low boiling point that even the heat from our hands will cause the vapor to rise and tip the bird. Thus, the high temperature of the boiling water caused the bird to tip extremely fast. Now, as the head tip dips into the cold water, the evaporation to cool the head is not enough to lift the bird due to the bottom still being very hot. Thus, the bird will continue drinking for a long time. And lastly, what happens if both the base and the drink are hot? Similar to the previous example, the bird's base being heated will cause the vapor to rise quickly and tip the bird. Now, as the drink is also hot, this will not allow for the head to cool, obviously, and thus the bird will stay drinking. The tippy bird is very reliant on temperature, and an increase or decrease in temperature to the base and or drink could completely change the movement of the bird.